Hello, I'm Richard with EV4U Custom Conversions, and today we're going to talk about energy use of lighting on your conversion and other accessories, but mainly the focus is going to be on lighting. How much energy does running the lights actually use? For a baseline information video, we're going to take a look at exactly how many amps the lighting on this Karmann Ghia draws from our pack. So join us as we take a look at how much current does it really take. Alright, here's a shot of our voltmeter. And here's a shot of the JLD showing the amps. The key is off, so we're not drawing anything at this point from our pack. I'm going to turn the key on, and we'll see the volt gauge go up, and it's charging. The DC to DC converter comes on when we turn on the ignition, and you can see it is charging our auxiliary battery. It's at almost 15 volts, and it's currently pulling 1/10 of an amp out of the pack. So now let's see what happens when we turn on the parking lights. This will be the parking lights only, the clearance lights. Let it kind of stabilize. So this is, the auxiliary battery and the DC to DC converter are sharing the load, but this is measuring what is being consumed out of our pack, our battery pack. So now I'm going to turn the headlights on. That's with the headlights on. Looks like we're pulling an amp out of our battery pack. Now I'm going to hit the high beam, see what that does. That's high beam. Let's increase the load. Let's pull on the emergency flashers. We can see with that load our voltage has dropped down just above 14 volts, and we're going between 1.4 and 1.6 amps out of the battery pack. So let me shut things down. Back down to just charging the battery. Key off. No more draw. Okay, let's up the load. That's what you saw with lighting on. Let's add a few things to the mix here. Okay, let's add few things here. I'm going to turn on the key. So right now that's the DC to DC converter charging. Again, our volt gauge. So this time I'm going to turn on the headlights. Headlights on. Take the high beam off. Okay, that's with the headlights. Now let's so we're driving in the rain, so we got our headlights on. Here's with the windshield wipers on. Well, we're going to add a few other things to the mix now too. Okay, turn on the ignition. Now you hear the cooling motor on our motor back there. On the traction motor we have the Garrett supercharger that's been retrofitted to be a cooling motor. So that's drawing 0.6 amps. And so now I'm going to introduce the all the cooling for the controller. We've got radiator and fans for that. So I'm going to kick that on. We have two different radiators and fans on this one. One for just normal driving, and then we get well over 100 degrees here. Last year we were driving around 118, 119 degrees. So we have a second one for those times, and I'll turn on both fans. And just sitting here in the shop, you'll hear them. But we'll see what it draws with everything on. Okay, what I've done is I flipped a switch that turns on the pump, the circulation pump for the controller cooling, as well as the both radiator fans. So now we have the motor cooling fan, blower going, as well as the fans for the radiators. Total of 3 fans. And so that's our normal draw right there. Summertime driving. That's what we're taking out of the pack with the ignition on. Now I'm going to add to that. I'm going to turn on the headlights. So that's with all the cooling on and the headlights. High beam. Emergency flashers. So that's pretty much maximum draw that we'll ever have on this car at any one time. Let's take a look what that did to our voltage. We're just below 14 volts right now. So you can see high beams on. That's the emergency flashers going. And that's what we're pulling out of the pack. Emergency flashers off. High beam off. Headlights off. All lights off. So that gives you an idea of the power draw on our traction pack. Power off. So there you have it. So you can see how much power the lighting draws, and as well as other accessories. So, hope you enjoyed this little video. Give you a little information. You've seen what the power consumption is with lighting, with our motor cooling, with our controller cooling, windshield wipers, so forth. That's the maximum that we don't have a stereo in this car. Is a commuter car. It's not designed for long trips, so I didn't bother putting a stereo in this one. Could easily be added. And so that would be the only additional draw really that you might have. Let's note that the lighting on this car is all stock incandescent lighting, and so this kind of gives you the maximum. With LED, I don't happen to have those readings to show you, but you can see that whatever difference there is between the incandescent and the LED, the incandescent usage isn't huge. And so we'll talk about that next. How much range is that lighting and our cooling and so forth? How much range is that taking off of the vehicle versus not having that load? So we'll go to the classroom for that and figure that out.
All right, we've done the readings from the vehicle. We've observed what the different accessories draw from our pack. And so let's do a review. Like I said, we observed them. I don't know if you were taking notes or not, but I was. And so the DC to DC converter, without any load, the battery fully charged, or I'm assuming almost fully charged, is drawing 0.1 amps from our battery pack. Then the parking lights, and this is a cumulative figure now that we're using here. When we turned on the parking lights, clearance lights, whatever you want to call them, we were drawing 0.3 amps. So here's what they were drawing by themselves, 0.2 amps, subtracting out the DC to DC converter draw. When we added the headlights to the scenario, they drew another 0.7, which took us to a total of 1 amp. High beam added 0.1 amps, so we're at 1.1. Emergency flashers added 0.4, bring us to a total of 1.5. And then the windshield wipers, just 0.1. So with all the lights on and the wipers, we were pulling a total of 1.6 amps. Now, it's interesting, and unfortunately I don't have a stereo system in this car, so we don't have that to add into the mix. But it's interesting, to me at least, that the wipers pulled so little and the emergency flashers pulled so much. I just, you know, that was an interesting observation to me. Just always assumed that the wiper motor would pull a little bit more. So the total for just the lighting, if you're just running the headlights, you know, not running the flashers or the wipers, just the headlights, our DC to DC converter, nighttime or wintertime driving, we're pulling an amp out of our pack. Okay? Now, we add the motor cooling, which you may or may not have in your vehicle. Karmann Ghia needs the extra cooling back in that rear of the car and kind of confined area. So we're running motor cooling, 0.6 amps. We can see that that's less than what the headlights draw. And then we add the controller cooling to the mix. The controller cooling consists of 3 fans and a pump. And those items pulled by themselves 1.1 amps. So no other single item pulled that much, my cooling. And the cooling is separately switched. So in the wintertime when I don't need it, I can shut it down if I want to. That's, you know, totally by choice and the flip of a switch. And so the total for cooling, motor and controller cooling that we use during the summertime, we always use the motor cooling, but the maximum that we will use is 1.7 amps. So the total consumption for the 12-volt accessories on that vehicle, that's lights, wipers, and cooling, is a maximum of 2.8 amps. So that's all interesting, but let's talk about that in relationship to range. How do the lights and the cooling and our 12-volt accessories, what kind of influence do they have on the range of my vehicle? Let's take a look. All right, this is what the pack is in that vehicle. It's a 14.6 kilowatt hour pack. It's using 100 ampere hour cells, and that means that I have 80 amp hours available. And the car has a 60-mile range on those 80 amp hours. So what that equals then, that works out to 1.33 amp hours per mile. So the lighting, which we, if you remember from the other side of the board over here, used 1 amp, that equates to 3/4 of a mile worth of range. So by using my headlights, I'm going to lose 3/4 of a mile. Or by not using them, I guess you could say I gain 3/4 of a mile. Depends on your perspective. All 12-volt items, all the 12-volt accessories will affect my range by 2.1 miles. Not huge. My driving style will affect my range much more than my 12-volt accessories. So let's look at this in another, what's the bottom line? Well, the bottom line is that my 12-volt accessories aren't a huge concern, at least to me. I'm never cutting it that close where, a few miles is going to make or break me. And I recommend that you don't put yourself in that situation either. But an observation out of all this is the LED lighting. If using the incandescent lighting, the stock lighting that came with the car, affects my range 3/4 of a mile, the LED lighting is going to consume a certain amount of energy. Because I don't have the LED lighting to swap out, put in that vehicle and do the comparison, I don't know what that exact figure is. But even if we put the LED lighting in and by magic it doesn't use any energy, the greatest benefit would only be 3/4 of a mile. So I guess my question then is, how important is it to you to switch over to LED lighting? Now, if you can get LED lights that are brighter and they're also going to be more efficient, it then becomes a decision of how valuable that is to you on a budget aspect. But at least now you kind of have a big picture understanding of what we're talking about. It's not a huge factor. And so then you can make your own choices. And that's what we're here for, is to help you be able to make good choices based on not perception, but reality.
All right, so we've talked about power out of the pack. So let's talk about, power back in. I guess a better term would be energy. The energy that we've taken out of the pack, and now we'll talk about putting energy back into the pack. And so we're going to show you the JLD as far as what is coming out of our charger and into our pack, and we're going to show you what's coming out of the off the grid and into our charger. So let's take a look. Okay, here's our watt-hour meter. We're currently showing about 117 volts, and power factor of 0.28, 60 hertz, and looks like we're using 1 watt, and that's with just my extension cord plugged in. It's a lit cord, and this is probably doing some rounding up. So let's so it's 0.05 amps. So let's plug her in and see what happens. We only use 110 on this vehicle. She's plugged in and charging. Let's see what that does over here. Okay, as the charger comes online, it's cranking up here. It has a slight delay, you know, as it goes through its startup sequence and then starts outputting. So looks like we're drawing just over 1400 watts, 1.4 kilowatts, 12.46 amps. Now let's go see what we've got on the other end. Well, here we are. This is the JLD 404, and it's showing we're putting 8.1 amps back into our pack. So I can see over the wall we're pulling 12.44. We're putting 8.1 in. So you can see it's not 100% efficient. But just to give you an idea of kind of the big picture, we're at 147.5 volts, and I've used 3.05 amp hours for my pack, which means it'll be charged here very quickly, probably about 20 minutes. Now I've seen it charge as high as 8.6, 8.7 amps. It's kind of dependent on the pack status, what the charge level is, and what the temperature of the cells are. We'll see a little variation, but and then this will drop down as it charges, gets close to completion. This is set up, the charger, it's an Elcon PFC 2500. It's programmed to shut off at 154 volts, which is 3.5 volts on our 44 cell pack. The JLD 404 is also programmed to shut off our controller at 154 volts also. So we have a redundancy there. It's also done where we're using the J1 while it's charging. J1's on, and when it gets 154 volts, J1 will shut off. Well, what's the significance in that? Well, if our 12-volt battery were to fail, then the charger would shut off. There's basically no way that this pack is going to be overcharged. We have, redundancy and safeties built in to where it's not going to exceed that 154 volts. As always, I hope you enjoyed this video. If you have any questions or comments, please email us at info@evforyounow.com. And if you enjoy our videos, why don't you subscribe to our channel, and that way you get notified every time we add a new video. See you next time.